So in section 8.2, the only thing that's different from this compared to 8.1 is that now we're going to use the t-interval, and that is because we have the sample standard deviation rather than the population standard deviation. So that's in a case where we don't know the reference population standard deviation. But the process is identical. The part where this gets tricky is if the student has a quiz or a test where these two are asked in the same quiz or test, which they generally will be, they have to see how to recognize it. So if the numbers are given like this and it says sample deviation S equals, that S is is a really good key to know that it's going to be a t interval rather than a z interval. Um, and so here we've got S as well, but some of them later on, it's not quite that obvious. Um, so it says here the average score was 5.41 and the standard deviation was 0.89. Um, it's still referring to that as being the standard deviation of this sample. And in the other ones, just encourage them to go back and look at how the wording is different in 8.1 versus 8.2. If their quiz is in Connect, then I don't have it in this particular screenshot, but in any homework problem, up in the right hand corner, it'll say what section that homework problem comes from. And if they're doing a quiz or a test in Connect, it still has that information in there. So in the easiest way to figure this out, if their tests and their quizzes are in Connect, is to look at that same place in the upper right hand corner as they would find it in their homework and look to see if this problem that they have comes from 8.1, then they're always going to use z interval. If it comes from 8.2, they're always going to use t interval. So that, if they're fortunate enough to have that option, is the easy way to do that. So for all of them, it's going to be just like, oops, not a second there. Oh, how do I get out of that? Quit. That'll work. Stat tests, and now we're going to do t interval. And the input for these at the beginning is going to be stats. Later it'll be data, and it's the kind of the same thing as before. So we've got a mean of 57.6 and a standard deviation of 9.5. Notice that now in the input it says Sx, whereas in the z interval it said sigma x. And then sample size of 47 and 99.5 confidence level, so 0.995, and calculate. And so here's our interval, 53.514 to 61.686. So that's all for these. And then would it be narrower or wider? There's going to be various other questions like that. Would something go up or go down? This is identical. This one, now we're using the word standard deviation. With a standard deviation, that's a good clue that it's talking about the sample standard deviation, because it's a sample has a mean and a standard deviation, as opposed to the population standard deviation being known and given. And so all of these are going to be done the same way up until we get to the data, and the data versions of them are pretty much the same as what was done in 8.2, but so of course, sorry, left out that step. So you'd have to go to edit and enter these numbers into L1. I'm just going to use the numbers here that I already have entered, and then stat tests t-interval. And now when we go into data, it no longer has a place asking for the population standard deviation, the sigma, and that's because we don't have one, and it's going to calculate the sample standard deviation from the numbers that we were given. So at this point, all we have to enter is L1, which will probably already be there, keep the frequency at 1, and enter in the confidence level of whatever you're given, in this case 0.99, and calculate. So that's the only difference here, is one fewer number to enter because you're not given a population standard deviation to use. Here we've got one that shows outliers. It's got this box plot and is asking us if the conditions for constructing the confidence interval are satisfied. This is a rare case where you're actually going to say no to that, and that's because there are two outliers. So anytime it gives you a box plot, it looks like this, and then the X's indicate outliers. If there are outliers, then you can't assume that the conditions are satisfied, and therefore the problem ends at that point because you can't do any of the calculations. But then going on to this one, and some of these are all problems from a while ago, so they're different, but they might not look identical, but same idea. So in this one, the sample size is less than 30, so we have to check and see if the data are normally distributed with no outliers. And so yes, the conditions are satisfied because it's normal-ish, meaning there's not a much longer tail on one end than the other, and the median here is sort of kind of in the middle of the box. This whole box plot thing, that comes up in a previous section. I didn't go over it in any of these videos, but it is in some of the videos that I've made for students in the past. So if you have no idea what this whole box plot thing is all about, you'll be able to find them there. And so it's just sort of like another way to represent a histogram kind of data. But if there's no X's, then there are no outliers, and then you can go on with the calculation. And that's the only different thing here. So that is all of section 8.2.